Hello y'all, today we are looking at 6.2. Hey, with my mouse. We're going to look at how we transform our probability models. Let's go. This is a lot of review. So if you didn't get it the first time, you get a second shot. Because what were we going to look at? We're going to look at what happens. We're going to look at what happens when we add or subtract a constant. We're going to look at what happens when we multiply or divide a constant. And then in B, we're going to look at what happens if we add or subtract the standard deviation and means of two separate random variables. And we'll find the probabilities of the normal random variables doing the same thing. Okay? It sounds really scary. It is not. This goes back to Chapter 2. In Chapter 2, we learned that if we have a distribution, because these are all distributions too. Recall from the last video. Okay? Hiya. Recall that if you add or subtract A, that changes the center, right? And it does not change variability, and it does not change the shape of the function. All right, think about it like this. Ooh, I'm going to try this pen tool. If you have a normal curve, right, and your center's 2, and you add 1 to everything, all that's going to happen, well, that stinks. If you have that, and your center's 2, and you add 1 to everything, your curve's going to look exactly the same, just shifted over 1. So again, center moves up 1, variability stays the same. Your standard deviation is not going to change up based on that, right? But now, if you multiply or divide, it will change the center and it will change the spread. Okay? Think about it this way. If I make $10 a year and my wife makes $100 a year, right? If we double our salaries, I'll now make $20 a year and she'll make $200 or $2,000, whatever I said. So it's more, instead of being, the difference between those numbers is increased when you multiply. Here, I'll do one more example because that was terrible. If I make $1 a year, my wife makes $2 a year, we both get our salaries doubled. I now make $2, she makes $4. The difference between those salaries went from 1 to 2. If she would have made $4, it would have went from 4 to 8. It would have been, the difference changes, so the spread changes. But the spread changes, but that does not mean the shape changes. Okay? If you're normally distributed, you'll still be normally distributed. Think about it this way. That's my salary curve at 2. And they double it. Now it's going to be, my center's going to be at 4. And it'll be a wider, more spread out curve. But still normally distributed. Okay? So remember that Crazy Pete from the 6.1a video? Crazy Pete and his randomly collected money for people. That's creepy. Creepy jeepy. So, if you recall, he randomly took, there's a 5% chance it costs you $900. There's a 20% chance it was $750, and so on and so forth. You guys can read, I hope. So now, Pete has to pay $100 for each trip he goes on. So instead of looking at how much money he brings in, we want to know what's his profit. So V is the amount of profit he makes. Whoa, 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 whoa. His profit is each of the numbers we had they charged minus 100. So this is the graph, the probability graph of his profit, not his revenue. There's a difference. The big thing I want to see is how do they compare. Here's our original, and here's our new one. Well, this one looks more spread. This is a bad representation, but you guys can kind of see it. If I were to overlay the one on the other, it would just be the whole thing would be shifted over 100, right? I'm not going to do that because I can't. I'm not good at things. So the shape's the same. The center moved down 100, and the spread is exactly the same as well. All right? It said you went from 300 to 900. Now you're going from 200 to 800. Okay? Spread not changed. Center is changed. Shape is the same. Awesome. Oh, cool. I gave all the same answer. So standard deviations, you guys can read. Take your time. Read it. Love it. Now, if we add or subtract a constant, again, mean, median, quartiles, percentiles will all change, and all you do is add or subtract what was to it. Your IQR, your range, and your standard deviation stays the same. Your shape stays the same. I feel like a broken record. So this is exactly the same as what we did in Chapter 2. All right? All right. Pause this, read it. I'm going to pause it and read it right now. So the kids took their test, worth 50 points. The mean was 35, standard deviation 5. The professor's an old softy. He's like, I'm going to give y'all 5 bonus points, a gift, a present. Oh, can you guys even... You guys will be fine. Okay, where can I put my face where it's out of the way? Down here? There you go. Watch, it's going to be in the way. No, it's not. So the shape's going to be approximately normal because it said so. We're going to take our center, and because we're adding 5, the original was 35. 35 plus 5 is 40. So the new center will be 40. The new average is now 40. Now, the standard deviation will not change. Because if the spread doesn't change, the spread is kept the same by adding or subtracting a constant. Now, when I multiply or divide, though, something else happens. Your mean, median, quartiles, percentiles changed by B, and your range, IQR, standard deviation all changed by B as well. So when you multiply or divide, every number gets multiplied or divided by the constant. Their shape is still the same. It's just going to look a little bit wider or thinner. Okay, it'll be like me in college. If you multiply by like 10, it'll be like me now. Great. Yeah, that's what I mean. Great. Yeah, get out the face. Why are you always in the way? Here, is this a good spot for it? No, now it's gone. I have to pause it now. Alright, so let's use that same example, but change it slightly. Shall we? Alright, never mind. Let's not. We're just going to use a completely different example. I had something else written down. So you can read it, pause it, know what's going on. Okay? Are you reading it? So here's our units, here's our probability, right? So there's our mean or standard deviation. Now, if tuition is 50 less, and T is your 50 times X, so tuition equals 50 times X, where X is your units. Okay, so think about it like credit hours, right? So you have 14.65 credit hours. They're $50 a credit hour, which is amazing. All right. I don't know why I said less. I don't know what I was thinking there. Who knows? So let's talk about this beast. So now, when you first look at this, you would say it's randomly assorted. There's stuff everywhere. But it's actually fairly symmetric, right? There's nothing pulling it from one side or the other. There's the same amount pulling on each side. It's like a balance. It's balanced. Okay? So, the shape would be symmetric with 3 peaks. Okay? Now, the center, our original center, we said the average was there's 14.65 units, right? So, we multiply by our constant. 50 times that 14.65. Come on, Mo. No! Why do I make such weird noises all the time? So that was our average. Yeah, black highlighter. Let's go. I'm going to times it by how much per credit yard. So I get the average of $732.50. So our original variability was that. I just times it by 50, and I get my new variability. Okay? You know what it is. Black and yellow. Black and yellow. If this gets flagged by YouTube, it's on me. I did not get permission.